Okay, let's have a look at the centre of gravity of some regular shapes to start with. So we have here a rectangle on the top left-hand corner, and the centre of gravity is halfway across and halfway up. So if the length across was 2a, the centre of gravity would be located at distance a across. If the height up was 2b in total, the centre of gravity would be located at height b upwards. If we look to the right, we have a disc or a circle. The centre of gravity of the disc is located at the centre of the circle, which is a radius in and a radius up in that case. And then the last one, a triangle, is quite unique. The centre of gravity is going to be closer to the wider end. And if we were to draw a line from any of those tips to the opposite flat surface, so that that line was perpendicular, so from top vertex we'll say it's straight down, so that that vertical line is at right angles to the base there, then the centre of gravity will split that line in the ratio of 2:1 always. So I got two arrowed dotted lines there. The top arrowed dotted line would be twice as large as the bottom arrowed dotted line. And that's the same if you go from any tip to the midpoint of the other side, which is perpendicular to the other side. They'll always be in the ratio, the lengths will always be in the ratio of 2:1 from the vertex to the centre of gravity and from the centre of gravity to the opposite side. Okay, that's just something to keep in mind. We'll do more of that in class. Now, to find the centre of gravity of a compound shape. So what we use is that if the object is rotating, then the moments of each individual part added up, which we call the sum of the moments, equals the moments of the total shape. So, in other words, the rotational effect of each of the individual shapes when they're added together will equal the rotational effect of the entire shape. Now, how we're going to represent that is on the left-hand side, we'll have mass by distance, plus mass by distance, plus mass by distance, plus mass by distance, depending on how many shapes we have. And on the right, we will have the total mass of the system multiplied by the distance between the axis to the centre of gravity. And it's typically that distance between the axis and the centre of gravity that we're looking for. Right, so here's your example. If we have a shape here which shouldn't be regular or shouldn't be labelled regular, and I'm assuming here it's a rectangle of mass 3m connected to a circle of mass m. The axis of rotation is that red dotted line, and the centre of gravity of the rectangle is a distance L away from the axis of rotation. The centre of gravity for the circle is a distance 3L away from the axis of rotation. So what we're going to do is we're going to look at the mass, which is similar to the weight in this case, of the rectangle multiplied by the distance of its centre of gravity from the axis, plus the mass of the circle multiplied by the distance of its centre of gravity from the axis of rotation should equal the total mass of the system multiplied by however far the centre of gravity of the system is from the axis of rotation. So we'll have a table. We'll have the mass, which is related to the weight of each of those two objects. We'll have the distance for each of those objects and also the total object from the centre of gravity to the axis of rotation. And we'll have a moment for the rectangle, the circle, and the total system. So let's look at the rectangle first. Well, the mass of the rectangle is 3m, so I'm just going to put 3m there. Its weight would be 3mg. The centre of gravity is a distance L from the axis of rotation, and then to calculate the moment or the turning effect of that rectangle, multiply the two of those, we get 3ml. Let's look at the circle. Well, the circle is of mass m, so its weight would be mg, but we're going to leave that out. And the centre of gravity is 3L away from the axis of rotation, so its moment then will be 3ml as well. So what we have now is the individual moments of the parts of the shapes. So what we're now going to say is the sum of the two of those, which is 6ml, should be equal to the total mass multiplied by however far the centre of gravity of the compound shape is away from the axis. So total shape, total mass, 4m. Now we're looking for a value for where the centre of gravity is, so I'm going to call it a general value x. And we know that if we added the two of those moments together, 3 ml and 3 ml give me 6 ml. So what we're going to say then is the sum of the moments equals the moments of the sum. So the sum of the moments will be 6 ml, and the moments of the sum, which is the moments of the compound shape, which will be the total mass multiplied by however far the center of gravity of the compound shape is from the axis of rotation, will be 4mx. And that gives me 6 ml equals 4mx. Solve for x, and I get 3l over 2. That says that the center of gravity of the compound shape is a distance of 3l over 2 away from the axis of rotation.